Imagine a place where you'd instantly freeze on one side and evaporate on the other. A world of brutal extremes, where logic seems to fail. A planet that should be a sterile furnace but hides vast deposits of water ice in its eternally dark craters. The cosmic puzzle of a world that is shrinking, yet still holds a magnetic field. Welcome to Mercury, the most extreme, fastest, and most mysterious planet in our solar system. The smallest of the giants, hidden in the fiery glare of the sun. Its story isn't just an astronomy lesson. It's a cosmic thriller of mystery and survival that humanity took centuries to even begin deciphering. For centuries, Mercury was an enigma. Its proximity to the sun makes it nearly impossible to observe from Earth. The blinding light of our star hides it in a constant glare, allowing only quick glimpses at dawn or dusk. This difficulty led to myths and confusion. For a long time in ancient Greece, it was thought to be two different celestial bodies, one that appeared in the morning called Apollo, and another in the evening, the swift Hermes. Little did they know that this messenger of the gods, which moves faster than any other planet, held secrets that would challenge everything we thought we knew about planetary formation and evolution. Its elusive nature kept it the least explored planet for decades, making it the hidden challenger of our cosmic backyard. And what makes it so fascinating is its size. Mercury is barely larger than the Moon, yet its small volume hides a colossal density, the second highest in the solar system after Earth. It's a disproportionately metallic world, a heavyweight in miniature, and this density is just the first of its extremes. Get closer to its surface and prepare for a world where life as we know it is a cruel impossibility. A master of thermal contrasts. Mercury has the greatest temperature variation of any planet in the solar system. On one side, the sun bakes the surface to over 430 degrees Celsius, hot enough to melt lead and vaporize some metals. Any trace of water would be instantly sunk. On the other side, on its night face, the temperature plummets to minus 173 degrees Celsius, cold enough to freeze gases that we on Earth would never see in a solid state. This extreme variation, over 600 degrees Celsius, is a direct consequence of its almost total lack of atmosphere. Mercury's so-called tenuous exosphere is so thin that it's unable to retain any heat, acting like a vacuum. Without a gaseous blanket, the heat and cold are extreme, relentless, and instantaneous. But here's the mystery that shocked scientists and the public despite its hellish proximity to the sun. Space probes have revealed that Mercury harbors water ice. The initial discovery came from Earth-based radar observations, which detected highly reflective regions at the poles, and was confirmed with neutron and camera data from the Messenger mission. But how is it possible for ice to survive in this cosmic furnace? The answer lies in an orbital quirk. Thanks to Mercury's almost zero tilt relative to its orbital plane, some craters at the poles never see sunlight. The sun, which is always low on the horizon at these poles, simply cannot penetrate the bottom of the craters. They are permanently shadowed cold traps. In these abysses of eternal darkness, the temperature is consistently maintained at around minus 100 degrees Celsius, cold enough to protect ice from comets and asteroids that impacted the planet, accumulating over billions of years. It's a counterintuitive, frozen oasis in the heart of a flaming planet. And what's it like to experience a day in this world of extremes? Bizarre. Extremely bizarre. While Earth spins rapidly, Mercury is a slow cosmic dancer, forced into a strange rhythm by the sun's gravitational pull. The planet rotates so slowly that it takes 58.6 Earth days to complete one rotation. But its orbit around the sun is very fast, taking only 88 Earth days. What happens is a 3-to-2 resonance, 3 rotations for every 2 orbits. This creates a peculiar temporal relationship for an observer on the surface. A single Mercurian day, from sunrise to sunrise, lasts an incredible 176 Earth days. This means, shockingly, that a day on Mercury is twice as long as its year. And the sun's dance in the sky is even stranger. Due to its elliptical orbit and slow rotation, at certain points in its orbit, the sun would appear in the sky, stop, briefly, reverse its course, and then continue in the original direction before finally setting. It's a temporal and visual nightmare that defies our intuition. The small planet is more than just a world of extreme temperatures and bizarre days. It's a geological body with a dramatic history of global contraction. What makes it so dense and heavy for its size? A massive iron core. This core makes up an incredible 70% of the planet's total mass, and extends for more than 2,000 kilometers in radius. For comparison, Earth's core makes up only about 55% of its mass. The origin of this oversized core is one of Mercury's biggest mysteries, raising the theory that it may have suffered a primordial catastrophe, perhaps a gigantic collision that stole most of its rocky mantle, leaving behind only the dense metallic core. And this core is not static. Mercury is shrinking. The phenomenon, called global contraction, occurs because the planet's iron core is slowly cooling, and this loss of heat causes its internal volume to decrease, and this contraction has a dramatic effect on the outer crust. Mercury's surface is literally wrinkling, like a dried apple. Vast cliffs, called lobate scarps, extend for hundreds of kilometers, some up to 3 kilometers high. visible evidence that the planet has lost about 7 kilometers in its total diameter over the last few billion years. It's the only planet in the solar system we know is shrinking on such a large scale. Despite its small size and ongoing contraction, Mercury still has a magnetic field. On Earth, our field is generated by a rapidly rotating liquid ion dynamo, but Mercury's field is relatively weak and, strangely, is offset to the north relative to the planet's center. It's an enigma. Is this field a remnant of a dynamo that is still actively operating, despite the planet's slow rotation and partially solidified core? This mystery is a primary focus of current missions. Unraveling Mercury's secrets has been one of the greatest challenges in space engineering. The journey so close to the Sun is not a simple straight line. It requires constant braking maneuvers and thermal evasion. The first to dare to get close was NASA's Mariner 10 in 1974. It made 3 flybys, but the planet's gravity kept throwing it off course, and Mercury's peculiar rotation only allowed it to map 45% of the surface. Even so, it revealed the magnetic field in the crater-filled surface. It was a fascinating glimpse, but one that left more questions than answers. 3 decades later, NASA sent MESSENGER, the Mercury Surface, Space Environment, Geochemistry, and Ranging mission. Launched in 2004, MESSENGER spent 6 years using complex gravitational maneuvers, or flybys, to finally enter Mercury's orbit in 2011. The probe needed a ceramic sunshield to survive the 350 degrees Celsius heat and fuel pumps to circulate fluids and regulate its temperature. MESSENGER mapped 100% of the surface, confirming the ice at the poles, the planet's contraction, and providing unprecedented data on its composition and magnetic field. It operated for 4 years in orbit before running out of fuel and crashing into the planet in 2015, leaving a legacy of immeasurable knowledge. Today, a new generation of explorers is on its way. Bepi Colombo, a joint mission of ESA and JAXA launched in 2018, is the most complex mission to Mercury yet, with 2 probes that will study the planet from different perspectives. It is scheduled to enter orbit in 2025, and even before the probes, Mercury had already been a testing ground for the greatest scientific mind in history. Mercury's orbit always showed a small but inexplicable precessional shift in its closest point to the Sun that Newtonian physics could not explain. It was Albert Einstein with his theory of general relativity who finally solved the mystery in 1915. Gravity, Einstein explained, is not just a force, but a curvature of spacetime caused by mass, due to its extreme proximity to the Sun and its very high speed. Mercury was the first observational proof that Einstein was right, validating general relativity. Mercury, the small metallic giant, the furnace with ice in its heart, continues to challenge our expectations. It forces us to rewrite the books on how planets form and evolve. The Bepi Colombo mission has a lot of work ahead of it. It will seek answers to crucial questions. Where did so much metallic material come from? Is Mercury still geologically active? Is the core still actively cooling and shrinking? How is its magnetic field generated and why is it so asymmetric? Mercury reminds us that, even in our own cosmic backyard, mysteries abound. It's a testament to the universe's limitless imagination, which far surpasses our own. This little messenger, hidden by the Sun's glare, continues to whisper secrets from billions of years ago. Which mystery of Mercury intrigued you the most? The ice in hell, the shrinking planet, or its orbit that proved Einstein right? Like this video if you were fascinated by this world of extremes. Share it with a friend who loves a good space mystery. And to make sure you do won't miss the next discoveries from Bepi and future journeys to the far reaches of our solar system, subscribe to the channel and hit the notification bell. The universe has more imagination than we do, and you won't want to miss the next revelation.